Hello, everybody. Thank you for joining us today. My name is Emily Kuda, and I'm Percona's Senior Marketing Manager here. We're going to get started in just a moment. For those of you that are just joining us now, I'm just going to conduct a little bit of light housekeeping. If you could raise your hand to let me know that you can hear me okay. Great. All right. So next, during this webinar, you're going to be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we're going to take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's database performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours or less, along with the slides. However, if you would like to download a copy of the slides now, I've made them available in the handouts section within the control panel. So with that said, I'd like to thank you for attending today's webinar as we talk about what's new in MongoDB 3.6, presented by Percona's Senior Support Engineer, Adamo Tonete. With that said, take it away, Adamo.
So thank you, Emily. Hello, everyone. Thank you for joining Percona webinar. And today we're going to talk a little bit about the MongoDB 3.6. So this is an overview of new features and enhancements we had in this version. So you may say MongoDB 3.6 was released almost 6 months ago. 4.0 is just right the corner. But we're going to walk through all these slides. A lot of changes in this version. We're going to focus on Changestreams, retrieval rights, sessions, causal consistence, schema validation. We're going to talk about security. There's a huge improvement in security. Some query enhancements, not only for the query day by day, but for the aggregation framework as well, and some miscellaneous changes in the code, like something that's worth to be mentioned. A little bit about me. My name is Adamo, Tonete, and I've been working for Percona for the past 3 years. I have 10 years experience on database, and 5 years was dedicated to MongoDB. I'm a MongoDB certified professional, and I'm based on São Paulo, Brazil. So this version was released in early November. We start seeing this in production in December for some customers, and others decide to start migrating right now. And this is one of the reasons why we're doing this blog post. The version 3.6 was the first version that demonstrates that MongoDB was going to have transactions. So this is like a breakpoint. So after 3.6, MongoDB is prepared to have transactions. And we're going to talk about this in the following slides. Like I said, significant security improvement we had. And the release has more than 1,000 tickets solved, like small fixes in White Tiger, fixes in the way that the application, the instance is going to perform the initial sync, and a lot more. So let's talk about Changestream. This is one of the biggest new features that are available in MongoDB, and it's going to help you in a lot of different things. So you may ask me, what Changestream does, how can I use this? And I'm going to go through what can be done with that. So I'm not sure if you need it for some reason to read the uplog, to make an integration, or even create alerts and create some metrics. So the Changestream can help you with that. So it's a feature that allow you to receive new data from the uplog. It's reasonable across replica sets and shards, which means if I have a Changestream open for some reason, I have an election, I can resume the process where it stopped. So for who is reading the uplog, I know for integration, it's very hard to keep tracking because we don't have an index and we don't have a stop point in the oplog. We can listen for different operations in the Changestream. We can capture inserts, deletes, replace. There's a command called invalidate, and also we can record updates. They behave a little bit different. I want to talk about this in details to make sure that it's clear how it works and how this can be used. Let's suppose you have a software, an application that for all new customers, we are going to send a welcome email. This can be a social, I don't know, social network or something like this. Every time that someone logins in, creates a new document, a new user in your application, you're going to send an email. So you have a listener, a change stream, capturing data from the collection, I would say, customers or profiles, and for each new insert, you are gonna send out an email. So once the insert happens, you're gonna receive the version of the document, the new version of the document, and then you can work on that. It's very similar to delete. The difference is like the document after the delete doesn't exist, so you know that a document was deleted, but you don't have the new version of the delete. Replace works a little bit different. We have both the previous version and as well as the new version, so you can choose what version of the document you want to see. So let's suppose you run an replace process, but you want to see the previous version of the document. So it's possible to do that with streams. We do have the invalidate, which is a command. It's not an operation in the database, because as I mentioned, because the change streams are reasonable, we need to tell the client, the application, that for some reason this change stream is not valid anymore. Let's suppose you have a database drop or a collection drop, so these streams are no longer sending data to the client, and then the client must be aware that this cursor is going to be closed. And I keep update as the last option, as the explanation, because it's a little bit tricky to explain how the update works, because you only have the deltas in the change stream. Let's suppose you are listening for updates, and I have the customers collection as well, and I'm updating my last name, for example. What I'm going to get from the change stream is only the difference, like only my last name, for example. I'm not going to have the entire document. I'm going to only have the delta, which means like my previous last name was, I don't know, Oliveira, and my next one is going to be Tonete. And I'm going to only receive the Tonete as difference between the documents. So it's different than replace, because in the replace you have both, and update you have only the delta between the document. Between the two versions of the document. We do have another option that is gonna look up for the version of the full version of the document, but there's a trick there. If the document is being updated a lot, it's gonna be the update change stream is gonna return the last no version of the document. It doesn't mean like the version in the update. If you are looking doing a look back, is going to be the next version after the update. So there is no guarantee here that the document that you're going to reading, the full document, is a valid is the last version of the document after the update command. Just to show how the application is going to see this, this is a change stream running in a collection called full. The command to run that is very simple. You can easily do db.full.watch, and it's going to show you all the operations that's happening in the database. Here we have the ID, which is the controller, which is the number that we can resume from. So we have this is like a bin data. It's controlled by MongoDB. We have the operation type. Here we see it as insert, And we have, like I mentioned, the full document. So the full document, the document that has been inserted, is x equals 2 plus the underscore ID. So depending on the size of the document, you can also use, if you want to use, you can use match. So I want to match only operation type insert and update, and I want to project just the field X. So it's possible to work with some aggregation commands here. Not everyone is compatible, but it's possible to filter what you are reading here. So this is how a Changestream looks like, I would say. So Changestream are ready to have, the MongoDB is ready to have 1,000 Changestream for each instance without performance degradation. So let's suppose you have 1,000 connections, each one listening for a different collection, for a different parameter. So it's okay to have up to 1,000 Changestream per instance, which is not always true when you are reading from the op log. And you can also have this in more than one machine. So you can open a Changestream from a secondary, for example. If you need more Changestreams than 2,000, you can have a third secondary, read from a third secondary, and then have 3,000 Changestreams. It's possible to go to more than 2,000, 1,000 per instance, but there's no guarantee that performance will be as okay as with less than 1,000. So it's tested and supposed to be for 1,000 connections. One important thing is that the Changestream is always going to send you a consistent value of the data. So it's very likely, in some, this is going to only send you data that is not going to be rolled back from the primary. So it waits for the secondary to confirm. It waits for the secondary to confirm. So it depends on right concern majority. And as downside of that is that the Changestream is going to take a few milliseconds to send you the information, to send you the new value of the document. But in my opinion, it's completely acceptable because you are changing speed per consistency, and I prefer to read consistent data. And you may ask me what can be done with that. Like I mentioned, it's completely okay to send emails. So we have a listening, and then you send out emails. You can create metrics. I would say how many times a document has been updated in the database. So you can have a listener with the Changestream increasing a value in another collection. You can create alerts. Let's suppose I don't know, maybe some document was removed from the database and you don't know who did that. You're gonna have this information, like this document was removed. Let's say this is like common now with the new data protection laws. Someone asks you to remove data from his social media from your application. So you can have a Changestream open, an application listening to that, and once you have the data removed, you can send out an email, say, hey, your data has been removed from our database. It's very, very similar to triggers. So if you work with the relational database, it's very similar to triggers. But the difference is that the Changestream itself doesn't perform any action in the database. So it's just, I would say, a pipe of data that some application needs to work with. So you have the data, you have what's changing, but the application is not the database is not as, I'm not gonna say smart enough, but the database is not prepared to perform action based on what is in the Changestream. So that's why I say it's very similar to triggers, but it depends, it relies on another application performing the actions for you. And like I said, for the downsides, performance is guaranteed until 1,000 streams per instance. You can have as much as you can, but performance is guaranteed until 1,000 streams. And it trusts on majority, so make sure that you have this prepared, configured in your database. We do have a blog post about this. Like I said, this presentation is all based on blog posts we are published in the past months. This slide is available for download here in the chat. If you want more information, how to use that, more like a live code, you can go to this post. And if you have more questions, please feel free to ask me through Twitter or at the end of this presentation. This is another nice feature. I would say that this is a very simple and very useful feature that MongoDB delivers in 3.6. It is retriable writes. Probably you have a lot of codes in your application to make the application resilient for elections, failures, all kind of things that can happen in an environment, in a cloud environment or in a local environment, such as I have a data center, the connection was broken between data centers and stuff like this. So what is retriable writes and what retriable writes can do for me? So the retriable writes are a feature, a very simple feature to work, I need to say, that's gonna retry or write if it fails. So it's simple as that. But there are some details that I'm going to discuss how it works. So for every single write, the MongoDB now 3.6 has a session. I'm going to talk about session in the next slide. And every time a write is happening in the database, we have a session collection with an ID with this transaction. And once this transaction is finished, the driver and the client is going to confirm and remove this from the queue of open transactions. So retriable writes will trust on that, on sessions, to give you the possibility to retry a transaction after, I would say, a memory, a problem with network, or if it's is an election happening in your database, it's going to wait until the election finish and then retry the write. So there is no need for try, catch, except in your application. So if you are not sure if your write was being confirmed or not, just turn on the retriable writes feature, and then the database and the driver will do that for you. And of course, it's not like that easy. You must have the version 3.6. The drivers must be ready for the version 3.6 of the database. MongoDB Server 3.6 is required. So even though your driver does support 3.6 protocol, your MongoDB must be at least 3.6. You must have write constant equals 1, so the transaction must be saved somewhere. Is the minimum expected. And for now, there's it doesn't work with multi-line updates and multi-line deletes yet. It doesn't work with inserts. I believe it's gonna change in the new versions, but it's a using an increment, for example. So this is a very nice example from my colleague, Tim Van Kort. And sessions. Nothing that I mentioned so far would be possible without sessions. So Mongo 3.6 start having sessions for user, which means that now it's easy to find, to trace who is performing queries, for who's performing writes, for I would say almost everything in the database. So how sessions can help me? Well, there are a lot of things that can be done with sessions. So let's suppose we have a long query running, and for some reason we got I don't know, maybe connection issue, and this query has been running for 20 minutes. And before sessions, it was not possible to resume to the cursor. And right now we can do that. So we have a session open. Session is going to time out if it's inactive for a while. I need to confirm the time. Not sure if it's 10 or 30 minutes. I need to confirm this, but you have now the sessions. Each query has its own session, so we can have multiple operations in just one session. I'm going to talk about this in a while. And now list all the sessions by the user. All the sessions, we can kill a specific session, not killing all the user connections, and we can also kill all the user and sessions at the same time. So now we have a kind of dependence of documents, of operations, also with sessions. And this is one thing that I'm going to talk about now. What we call causal consistency. So considering that we have sessions, and we can have like a kind of a start transaction. It's not really start transaction yet, but now we can guarantee that the operations are going to happen in a specific order. So we open a connection, we are going to perform a few inserts, and then we're going to update, and then we're going to delete a document. We can guarantee now that we're going to have consistency among those operations. So what is the idea of causal consistency? We can have multiple independent operations running in the database. So we have multiple users running multiple inserts, multiple updates. But if we need, for some reason, like one order to be considered, we can use the causal consistency for that. So causal consistency will work for one session, of course. So we cannot have causal consistency for more than one session. And this takes advantage of sessions. Like if we perform inserts in the primary and we need to follow order in the secondary, we can also use causal consistency as well. With causal consistency, along with sessions and tunable consistency, we can make sure that we are reading our data in the secondary as well, in the same way that we did in the primary. So causal consistency is very useful when operations are related to each other, and you need to specify, to confirm the order of the operations. Make sure that the commands are going to be applied in the same order as it was applied in the primary. It's a very nice feature as well. Schema validation. Well, we all know like MongoDB is a schema-free database, but for some business, for some companies, some schema validation are really necessary. This is not a new feature in MongoDB 3.6. It starts in 3.4, so we have a schema validation, and now we have a more strict schema validation. So if we compare, this is a little bit more complicated, I would say, but it gives you gives the idea of creating a table. I'm not going to say it's creating a table for who comes from the relational, but you can ensure that it's possible that the document is going to have the data type that you expect to have. Because some customers and some people has like the collection customers, and some people save age as integer. Others, I don't know, maybe write old as age or use strings. And this can be a problem when you are exporting this data to a third-party tool, for example, if you have a business intelligence that needs to read this data. Or even if you are exporting this data to a relational database, to a strong type of database, like a relational database. So with the schema validation, it's possible to make sure the fields are present in the collection. So we can say, I want the name, age, and last name to make sure. I want to make sure that those are available in my document. And you can also change the behavior. So you can just send, I would say, like a warning. So this document doesn't fill the minimum required. You can stop the action. So if you set the warning, the level of strictness, I would say, to high, the document's not going to be saved if it doesn't follow the pattern that you previously defined for the collection. So this is one example of a schema validation. This is the same example as the document that I've created at the beginning. So I'm saying that my collection test, not collection full in that case, is gonna, the X field is required, and the X field must be a number, a Bisel type number, and I also have the description. So it's very likely to creating a schema, a full schema. And I have more options, such as if I want new fields to be added, or if I want all the documents to be like this, just the X value and the underscore ID value, and nothing more. So you can validate. You can use all the Bison type, like date, time, string, array, and all the other stuff. But here you are telling MongoDB how the document must look like. This, there's two ways to do that. This is using the JSON Schema command with the validator. But if you wanna, you can do that with a query style type. I use a different, a little bit different document here to make sense. So here I'm creating a collection. I'm saying that this collection must have the name as a string. The email must be true. The regex, all email must be at percona@.com. And the status, all the valid status are active and inactive. So we have two types of schema validation. This one is a little bit more detailed, and this one is also valid and very similar to the previous schema we had. So let's talk a little bit about security now. This is, for me, this is like what we expect for a while. This is very important for safety reasons, to avoid data ransomware, and how we saw in the past with MongoDB. So now it's impossible to have MongoDB listening to 0.0.0.0 by default. So this was the behavior of MongoDB before version 3.6. So we can kind of blame MongoDB to do that, because by default MongoDB was listening all the parts, and now it only listens to localhost. So you are only able to connect to localhost by default. So there's no way to install MongoDB and have external access to this database. Another very nice feature added to this security improvement enhancement is now that we can restrict user and groups to authenticate from a specific IP. So it's very similar to MySQL. We can create a user and say, hey, this user must come from the IP, I don't know, 10.30.0.0./16. So this will make sure that my client is connecting from where he's supposed to connect, and my server as well has the same IP number. So we need to whitelist the IPs. It's not the default, we can still working like before, but once you whitelist an IP, the communication must go through those IPs. If you have DNS, it's going to resolve the DNS and validate if it's a valid client and a valid server as well. So important things about security, it only listens to local host. So if you are deploying a MongoDB cluster right now, make sure that you are changing your IP, your listen IP. If you have more than one network card, if you have more than one IP, you need to specify both. You need to add another parameter, say I want a MongoDB to listen in both network adapters. Otherwise, it's going to only listen to localhost. And for the client side, it's a very nice, very useful. The client can only connect through a specific IP. We don't have yet roles based on the IP like MySQL does. We have a different access, different grants according to the host. But everything points that we are going to something very similar to this in a future version. Some query enhancements. There was a lot of query enhancements, a lot of comments, both for aggregation, for day-by-day usage, mainly for arrays, because it was terrible working with arrays with MongoDB. We have a new command called express. It is expression, ESPR. So we can now create expressions in the query. I'm not gonna say it's very similar to case, the idea of the case, or if you come from programming. So you can work with that and have a true or false to decide which update or which action to perform with a specific field. I'm gonna just do an overview about this. I have an example of array filters and date from string. A lot of people used to save data as a string, date as a string in the database. Some also used to save the date and the hour in different fields. So now it's possible to easily transform this in an ISO date in MongoDB and take advantage of that. There are a couple of different commands like array to object that we can transform an array in an object, and also we can transform an object in an array. We can merge objects, we can merge arrays, and stuff like this. This is one example how the array filter is going to work. So we have here an input. Let's suppose we have the A field with an array 0, 1, and 3. And then we're going to update everything, like there's no where condition here. We're going to set the array, the index of array equals to where this is the array filters, where my I here is equals to 0 or 3. So we're giving a name for the values of these arrays, and if it's 0 or 3, we're going to update this. So the final output is going to be 2 and 2. This is important when we have a lot of different arrays, so we can have different array filters. Using query expression, we can use, like I mentioned, expression. So if I it's greater than 1, I want to set this for 3. I want to set this for 5. There are a lot of different array operations that can be made. At the end of this part of the presentation, I have a link with a lot of different examples. But this is the idea of array filters. So we can now perform actions based on the value of the array. This is an example of a date from string. It's very straightforward. You're going to use aggregate, and in the aggregate operation, we have date from string. So we're going to copy the value of the date here. See, it's a string, and then we're going to transform this in an ISO date. So it's going to save space in the database because no longer saving this as a varchar. So we have not a varchar, string, and now we're saving this as an internal Unix timestamp inside of the database, inside of the JSON document. There are other chains in the database. small changes, but they are important to mention. So for version 3.6, we can change the uplog size online, so there's no need to take an instance off of the replica set and then change the uplog size. So this can be done online. This is true only for White Tiger, so it's not true for MLOp yet. We do have intra-shard and clients compression. So before 3.6, we had intra-shards, but now we can have a client talking to a MongoDB, a MongoD, or a MongoS using compression. So this can both use snap compression to save network throughput. So you can have you can use less network to have the same result, the same answer. So it's kind of having White Tiger size through the wire. So you have the document in memory, which is not compressed, but the answer can go to the client as a compressed data. We have a couple of improvements in date, working with date. We have improvements in time zones. And for Percona server, for MongoDB, we do have White Tiger hot backup available as well. We are deprecating RocksDB in version 3.6 because of sessions. So we don't have the ability to control sessions in RocksDB. This is going to be deprecated. It's like it's an architectural problem. It's not like RocksDB is not a good storage engine, but we are going to deprecate this. And we do also have all the enterprise grade features for MongoDB available in Percona server for MongoDB. So that's all for now. I'm open for question and answer. And save the date for Percona Live Europe in Frankfurt. It's from 5 to 7 November 2018. Thank you very much.
Thank you. Well, thanks for that, Adamo. So at this time, go ahead and enter your questions down in the questions field down below. As a friendly reminder, we're going to take time to answer as many questions as we can. So with that said, our first question is, can we include the password expiration date when creating the user access or privileges?
I need to check. You know by heart, but I'm just going to check.
Okay, no problem.
Yeah.
The other question is you were mentioning all of these are the blogs mentioned from Percona, correct? On all of these updates?
Yes.
So where can we find, or what's the easiest way to find all of these different blogs?
All of those are in Percona blog post. We have a filter for MongoDB. You can easily click on MongoDB, and then you're going to see the series of posts that we made for 3.6 version.
Great.
So we have a couple of different.
I'll make sure to also include that in the follow-up email as well.
Yes, I can add this to the presentation as well at the end, so it's going to be easier to get those.
Great. Let's see. We've got one more question. Let's see. That's come through. I'll give a couple more minutes to see if there's any other questions. Our question is, this is more or less for MongoDB developers, but do we have any solution for MongoDB master multi-DC or in the future?
We don't have master for MongoDB, but using shard, we can do something similar, but it's not gonna be like master. We can have tags, and we can have a master in one side of I don't know, maybe one data center, and then not master, one primary, and another primary in the other data center. There are replica sets, and we can replicate those. Like we can have secondaries in a different data center. So it's gonna be very similar, but it's not gonna be master. By the architecture, MongoDB is not a master database. So we can kind of have something similar, but it's not gonna be like master. And regarding the first question about user, I'm not aware of any parameter to expire password when creating a user in MongoDB until version 3.6. I need to check, and I can give a feedback later. Please send the email to Emily, and then I can reply.
And just a quick reminder, you can reach me at emily@percona.com. I'll put it in the chat window in case anybody has any questions that they maybe forgot to ask or need to provide more details. Okay, so our next question is MongoDB Changestream for Kafka?
Oh, sorry, Emily, I lost part of the
Oh,
question.
I'm sorry. Is MongoDB Changestream for Kafka?
Once you are able to read the Changestream, you can use whatever I would say application that you want. So I'm not expert in Kafka, but I believe if you can parse JSON documents, you can easily stream this for Kafka, for any kind of database. But it's going to depend on the third-party application or on-site application that you made for this reason.
Okay, that helps a lot, Adamo. So we do have a couple more minutes. I'm going to just wait a little bit just to make sure that there's no other questions. All right. Well, I think that's actually all of our questions for today, Adamo. Thank you.
I have the answer. Yes,
sure.
for the expired passwords. I was checking here. It is in backlog. This ticket number is 3197. So it's in the backlog. So there's no option yet to expire password after a period of time yet for MongoDB. Last update was in May 8th, so it was like a few days ago only, but it's still in the backlog for future versions.
Oh, that's good to know.
Yeah.
Thanks for finding that out, Adamo. All right. Well, I guess we can conclude early, give everybody back 15 minutes in their day. Thank you so much for attending today's webinar. And thank you so much, Adamo, for presenting today.
Well, thank you. Thank you very much to everyone for joining Percona webinar. Thank you, Emily.
Thank you. Bye.